Hi, myself S. Lakshmana, working as Assistant Professor in Department of Cybersecurity, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss uh, definitions and terminology on Introduction to Computer Organization. So, in this Introduction to the Computer Organization, we will discuss some definitions on the terminology. So let's start with the basic definition, that is a computer. So computer is an electronic device that can be programmed to accept the data, process it, and generate the results. So this computer is made up of, it is an electronic device. So it is made up of some electronic components, and it is programmed to accept the input data from external input device, and after accepting the input data from the input device, the CPU will process that input data, then it generate the results, and the generated results, it will be given to the uh, user for the visual purpose, or in different forms like text or audio, video, something like that. So it generate the results. So mainly this computer organization, it has three primary subsystems or components. So mainly it has three subsystems. The first one is the CPU. CPU is a central processing unit. So the CPU, again, internally it has three parts, that are ALU, arithmetic and logical unit, control unit, and some internal registers. Now coming to the second one, memory subsystem. So memory subsystem, because the memory, it is one of the important part in the computer, because we are storing several programs and data inside the memory. Okay, so that's why we require the memory. And the third one is a IO subsystem. So IO subsystem, it provides a facility to interact with the outside world, because the computer, itself, it cannot take the input. So that's why the input has to be come from some external input device. So that's why the computer is connected with several input devices and output devices. So this IO subsystem, it provides an interface or facility for interacting with the outside world using some input devices and output devices. So mainly the CPU, it plays a crucial role, vital role, because the CPU, it performs various operations. Okay. So all these subsystems, they function together as a single unit to deliver the desired output. So by grouping all these different components as a single unit, they are working, all these modules working together to get uh, to get the desired output. So that is a computer. So this is a basic computer organization. So it has three parts, that are central processing unit, next memory unit, and input device and output devices. So these input devices and output devices are both, we can form as a IO subsystem. Okay, so in the central processing unit, we have three parts again. First one is a control unit, ALU, arithmetic and logic unit, and some of the registers. So some internal registers are there. So a register is nothing but a group of flip-flops. It is a storage device. Okay, it is a storage. So we have different sizes of the registers. So that are 8-bit, 16-bit, 32-bit, and so on. So using a 8-bit register, we can store 8 bits of data. So register. So register is nothing but it is a collection of flip-flop. So flip-flop is nothing but it is a single bit storage device. Okay. And ALU, so arithmetic and logic unit. So this unit, it performs various arithmetic operations like addition, subtraction, multiplication, division, increment, decrement, and so on. Similarly, it also performs the logic operations like and, or, XOR, not, complement. So these are all the different logic operations that are performed by the this ALU, arithmetic and logic unit. And the control unit is it is used to generate various timing and control signals, because the computer, it consists of various modules. So in order to work all those modules properly, it requires some timing signals and control signals. So the timing and control signals are generated by the this control unit. And input devices and output devices. So input devices. So we have different input devices like some keyboard, mouse, joystick. So these are all the various input devices. Similarly, output devices are some speakers. Okay, some speakers, monitor. Okay, so these are all the output devices. So inside, just before, we have seen various modules. So in order to work properly, all those modules are interconnected using some system bus. So that is called system bus. So all those modules are connected through some bus. So what is bus? Bus is a collection of connecting wires, collection of physical wires. That is called bus. So what is system bus? So a system bus is the main bus which contains address bus, data bus, and control bus. So what is system bus means a system bus is the main bus. So it is a main bus, and that consists of address bus, data bus, and control bus. So these are so that means the system bus, it consists of all these three buses. Okay, so that is called system bus. Bus means collection of physical wires, collection of physical wires. That is called bus. So what is address bus? Address bus, a bus which carries address information from CPU to the memory or I/O device. So so the CPU is connecting with the memory as well as some I/O devices. So you can see here. So the CPU, it is connected with memory subsystem and I/O subsystem. So I/O subsystem, it consists of several I/O devices, input or output devices. So if the CPU wants to access any particular memory location of the memory, or if the CPU wants to access any I/O device, then it can access through the some address, because if the CPU wants to access the memory, so every memory, it is having some unique address. Suppose the address for this particular location is some 4000. So this is the address. Okay. So if the CPU wants to read the instruction in the 4000 location, then that 4000 address will be sent to the memory through the address bus. So through this bus. So this bus is the address bus. That means a bus which carries the address information from the CPU to the memory. That is called address bus. Not only to the memory, but also the I/O devices, because every I/O device, it is having certain address. That address is in the hexadecimal representation. So that suppose, let us assume this is some input device, keyboard, and the address is 7FH, because H is a hexadecimal, because the address of every I/O device is in the hexadecimal representation. So suppose if the CPU wants to use the keyboard with the address 7F, then that 7F address will be transmitted to the I/O device through the address bus, which is connected to the I/O device. So if the address generated by the CPU is matched with the address of the I/O device, then the connection will be made between the CPU and the I/O device, so that the CPU can start reading or writing the data from and to the I/O device. Okay, so in this way, the address bus is useful. And second one, data bus. So data bus in computer architecture, The data bus is wired connection dedicated for the transmitting the data between the CPU, peripheral devices, and other hardware components. So this data bus, especially, it is used for transferring of data from the CPU to the peripheral devices or and other hardware components. The data bus is a part of the system bus in addition to the address bus and control bus. So here you can see this is a data bus. This is a data bus. So the data bus is a bidirectional in nature. So bidirectional. That means we can transfer the data from CPU to the memory or from memory to the CPU. Similarly, we can also transfer the data from the CPU to the IO device or from IO device to the CPU. So that's why the data bus is a bidirectional, whereas the address bus is a unidirectional because the CPU it has to only accept the address to the particular memory location, particular memory subsystem or the IO device. So that's why the address bus is a unidirectional, whereas the data bus is a bidirectional. So the data bus it is used to transmit the data from the CPU to the memory or to the IO device. And coming to the third bus, that is called control bus. The CPU contains a control unit which controls the functioning of all other components connected to the computer system. So the CPU contains, so already we have seen in a previous, so the CPU it consists of three parts: ALU, control unit, and registers. So the control unit which controls, so this control unit which controls the functioning of other components connected to the computer system. So the aim of the control unit to control various components that are connected to the computer system. And the control bus is used to transfer the control signals from one component to the another component. So the control bus which carries the control information like read, write, clear. So these are all the control signals. Okay, so read. So that means it controls how the data is read from. Similarly, write. So to where we have to write the data to that particular device. So this control bus which carries the control signals like read and write. So this control bus also it is a bidirectional. It is a bidirectional. Okay, so these are the about the various buses. So bus means it is a set of physical wires. And coming to the peripheral devices, so input or output devices that are connected to the computer are called peripheral devices because we are connecting several input or output devices with the computer. So these input or output devices we can also call the peripheral devices. So these devices are designed to read information into or out of the memory unit upon command from the CPU and are considered to be part of the computer system. These devices are also called peripherals. So the examples of the peripheral devices are keyboard, display unit, printers. So these are all the common peripheral devices. So these peripheral devices mainly are classified into three types. The first one is the input peripherals. So these input peripherals allows user input. So that user input from the outside world to the computer. So these input devices they will allow the input to peripherals allow the computer to read the data from the external world using some input devices. So that examples of the input to peripherals are keyboard, mouse, trackball, joystick, microphones, and webcams, etc. So these are all the various input peripherals. Once the computer accepts the input data from the various input peripherals, then the CPU will process, then it generate the results. So the generated results will be given to the user using any one of the output peripherals. So output peripherals allows information output. So that means these output peripherals allows the information to be transmitted to the external world using some output peripherals. So the examples of the output peripherals are printer, monitor, plotter, projector, speaker, and headphones. And the third one is a input output peripheral. So that means some these peripherals they acts as both input as well as output. So the examples of the input output peripherals are touch screen and hard disk. So these two devices acts as a input output peripherals. And coming to the instruction cycle. Okay, so what is instruction cycle? Instruction cycle is the cycle that the central processing unit follows from boot up until the computer has shut down in order to process instructions. So instruction cycle we can also call fetch, decode, execute cycle. So this is called instruction cycle because the instruction cycle is the time required for the CPU to fetch, decode, execute an instruction. So that is called instruction cycle. So a program resides in the memory unit of the computer consists of a sequence of instructions. So in general, the program it will be stored in the memory. So program is nothing but set of instructions. So that instructions first that will be fetched from the memory. Fetched from the memory. After fetching, it will be decoded. Then it will be executed. So let's see what are the different phases of the instruction cycle. So the instruction cycle is divided into sequence of subcycles or phases. So mainly it has four phases. First one is the fetch. Fetch an instruction from the memory. So if you consider a memory, so in the memory we are storing a program. We are storing a program. So program is nothing but set of instructions. So that means a set of instructions. So this is a first instruction, second instruction, third instruction, fourth, fifth instruction. Like that, all the instructions will be stored in the memory. So here, so first step is a fetching. So the first instruction will be fetched from the memory. So fetching is nothing but retrieving the instruction from the memory. That is called fetching. After fetching, then it has to be decoded. Okay, so decoding is nothing but uh, we are writing the program using some high level language or assembly language program. So as a human we can understand the high level language or the assembly language, but the machine cannot understand because the machine can understand only the machine language, nothing but zeros and ones. So that's why our the instruction which is written in using high level language or assembly language, that will be converted into the machine understandable language. Then it will interpret the operation. That means what type of operation it has to be performed. So that will be decided in the decoding phase. So decoding the instruction. Once decoded, then it read the effective address from the memory if the instruction has an indirect address. So mainly the instructions have two types of addressing, that is indirect address and direct address. Suppose if the direct addressing is there, then no need to calculate the effective address. So this third phase it is applicable only if the instruction is having indirect addressing. So if the instruction is having indirect address, then it has to read the effective address from the memory if the instruction has an indirect address. After reading the effective address, then it will execute the instruction. It will execute. So execute the instruction in the sense implementing those operations. So the example is add a comma b. So here opcode is a and operand is a comma b. So that means here this is add. So in the decoding phase, the CPU will decode this instruction. That means it will decide what type of operation it has to be performed. So what is the operation here? Add, addition. So it will decide to perform the addition operation. Okay. And the last step is the execute. Execute means it performs the addition operation. That is the execution. So these are the different phases of the instruction cycle. First one is a fetch, decoding, and read the effective address if the instruction has an indirect address, and execute the instruction. So here you can see the in a graphical form. First one is a fetching, decoding, read the effective address from the memory, and then executing. So if the first instruction completed all these four phases, then only the second instruction will be starts fetching. Again, the second instruction, it has to fetch, decode, read the instruction, read the effective address, and then execute. Then only the third instruction will be fetched. So like that, all the instructions of the program gets executed. And coming to the memory. So memory, main memory. So main memory is a RAM. So RAM is considered as the main memory. So the RAM. So RAM means a random access memory. It is a volatile memory. It is a volatile. So volatile memory means if the power fails, then the content stored in the memory gets erased. So that is called volatile memory. And every file or application opened is placed in RAM. Okay. So suppose in a computer or system, if you open any application or file, then it will be then it will be placed in the RAM. Okay. And it uses random access technique. So random access technique means the data can be directly jumped to the middle if necessary without having to read the data sequentially. So that means randomly. So that means the memory, it has several memory locations. It has several memory locations. So here in the random access memory, no need to go in a sequential manner, one after another. So we can directly jump from one memory location to the required memory location. So that's why it is a faster to access, random access technique. And this random access memory are two types are there. One is a SRAM, we can call static random access memory, and the second one is a dynamic random access memory. And coming to the second type, that is a ROM. So mainly the memories are classified into two types, RAM and another one is a ROM. So ROM means a read only memory. So ROM is a non-volatile memory. Non-volatile memory. That means even if the power fails, the data stored in the memory will be there. That means no data erased even the power fails. That is called non-volatile memory. So the instructions are stored by the manufacturer. So these in the ROMs, the programs or instructions that will be loaded by the manufacturers at the time of manufacturing. Okay. And the examples are the memories that we are using in the consumer appliances or home appliances. Suppose if you consider a microwave oven. So in a microwave oven, we are using this ROM memory. So inside that ROM memory, we are the manufacturer will be stored a program corresponding to the functioning of the microwave oven. So that is a program. So that will be loaded into the this ROM memory because it is a permanent memory. So that's why that program will be loaded into the ROM, and from that program will be executed. So it stores bootstrap program. It stores bootstrap program. So what is the bootstrap program? Bootstrap is a instruction required to start a program. So that means when we start any computer, initially some booting process will takes place. So that means internally some programs will be executed in order to turn on the computer. So that boot up program are stored in this ROM because of this non-volatility in nature. And some special programs are called stored called micro programs, which deal with low level machine functions. And coming to the types of ROMs, so we have different types that are MROM, masked read-only memory. So this masked read-only memory are these are oldest type of ROMs, and these ROMs are in these MROMs. The program will be loaded by the manufacturer at the time of manufacture. So the user cannot load any program into this particular MROM. And second type is a PROM, programmable read only memory. So this programmable read only memory is a these PROMs are available, empty PROMs are available in the market. So using a IC programmer, using IC, that means using a memory programmer, we can um, we can load the program into this PROM. So it is a PROMs are one time usable. That means only one time the user can load the program into this PROM. Once the program is loaded into the PROM, then user are not able to erase. Then second one, EPROM. So EPROM, erasable and programmable read-only memory. So in previous one, PROM, user can only one time the program can store inside the PROM. But whereas in the EPROM, the um, user can write program into the memory several times and also erase the program several times. That means multiple times loading the program, loading or storing the program into the memory and erasing is possible. Okay, so that means multiple write and erasable. Next one, EEPROM. So EEPROM means electrically erasable and programmable read-only memory. So these are they can withstand for longer duration, and similarly this EEPROM also the data inside the PROM can be erased by exposing this EEPROM to the ultraviolet rays for the duration of 4 to 10 milliseconds. But whereas in the EPROM, it takes some 1 hour to 2 hours for erasing the entire memory chip. But whereas in the EPROM, it takes around 4 to 10 milliseconds to erase the entire memory chip. And also in this EEPROM, uh, 10,000 times we can load the program and we can erase the program. So that means these many times we can use this EEPROM. And coming to the last one, it is a flash memory. So this flash memory is an advanced version of the EEPROM. Okay, so these are the different types of the ROMs: MROM, PROM, EPROM, EEPROM, flash memory. And coming to the traditionally, the computer programming languages are divided into the following categories. So mainly, the computer programming languages are classified into these types. First one is a high-level language, and second one is a low-level language. So again, the low-level languages are classified into assembly language and the machine language. And first one is a high-level language. High-level languages are much closer to human language because nowadays all the programs we are writing in using the high level language. Okay, because the high level languages are much closer to the human language. That means writing a program using some English words, that is nothing but a high level language. And the examples of the high level programming languages are Python, Visual Basic, Java, SQL, C++. So these are all different examples of the high level languages. So these high level languages they possess a high level of abstraction, and these high level languages as they have been developed to make it easier for programmers to read and write the programs, because the programs reading and writing in a high level language is very easy. So this is because high level language code looks like normal human language. And this high level language or platform independent. So this is a main advantage with the high level language, because it is a platform independent. That means the same code you can run in any computer with any operating system, any processor or any operating system, without modifying the program. So that's why it is called platform independent. So that means the program code can be converted and run on computer with different microprocessors and different operating systems without modification. Then high level language must use interpreter, compiler, or translator to convert human understandable program to the computer readable code. Because as a human, we can understand the high level language, but the machine cannot understand. So that's why the program written in high level language that will be converted into the machine understandable language using the compiler. Coming to the low level language. So the low level language have low level of abstraction than the high level programming languages. So because of this, low level code is more easily read by computer and it is faster at a runtime. So this low level language are again two types are there. One is a assembly language and another one is a machine language. So assembly language is a language to machine code, closest language to the machine code. So assembly language is a closest language to the machine code. However, assembly language gets converted into the machine code by an assembler. So we are writing programming program using some assembly language like some mnemonics like add a comma b, increment a. So that means we are writing using mnemonics. This is called mnemonics of codes. Okay, so the programming writing using this mnemonics is called assembly language. So the processor cannot understand this assembly language. So that's why using this assembler, it will convert the program written in assembly language to the machine understandable language. So that is a assembler. Each processor has its own assembly language. So every processor it is having its own assembly language, because if you have 8086, suppose if you have 8086 microprocessor, it has its own instruction set. Similarly, if you have 8051 microcontroller, it has its own instruction set. Okay, okay. So a program written in assembly language of one processor cannot be run on a computer that has a different microprocessor, with a very important exception, because instruction their instruction sets are different. So that's why the program written for one microprocessor cannot run on another processor. And a company that develops microprocessors will usually design new microprocessors so that they are backward compatible with its previous microprocessors. So example, Pentium 3 microprocessor. So it is one of the important feature in the microprocessor, because every microprocessor it has to be backward compatible, so that the all the programs which is written for its previous versions, they can run on the current version. And coming to the machine language, so machine language is nothing but the language which can understand by the computer. That is called which can understand by the computer or processor. That is called machine language. And machine language is nothing but zeros and ones. So the machine can understand only zeros and ones. So machine language or machine code is the only language that the computer can understand and receive instructions. These machine instructions are often either binary or hexadecimal code. So binary is a system of using zeros and ones. Okay, so if you see the example of binary that creates the word hello, so this is a HELLO. So as a hello, because this hello is written in using English, so that as a human we can understand. But the computer cannot understand this hello. So this every character it is representing in a binary for understanding of the processor. So let's see. So H is represented in some coded form 0 1 1 0 1 0 0 0. Similarly, E also represented in 0 1 1 0 0 1 0 1. So like that. So only this language, this language can understand by the processor. So this is a machine language. And coming to the compiling and assembling the program, compiling and assembling. So once the programmer has written a program in high level or assembly language. So in general, we will write programs using some high level language like C++, Java, SQL. Okay, so using the some high level languages. Similarly, we are writing programs using some assembly languages also. Suppose if you write a program in high level language, then that high level language will be converted into the machine understandable language using compiler. So all high level language programs should be compiled so that the computer can understand. So what is compilation? So compilation is the process of converting the high level language program into the into the machine understandable language. That is called compilation. So in the compilation, it also checks for any syntax errors. And after that, assembly. So that means, suppose if you written a program in the assembly language, then using the assembler, that assembly language program will be converted into the machine understandable language. So in this way, using compiler and assembler, we can convert into the machine understandable language. So compiling. So a program that changes the source code. Source code is nothing but the program which is written in the high level language to the object code. Object code in the sense machine language equivalent of the source code, which that can be executed by the machine. So during compilation, it checks for syntax of the program and checks all the program at a time. So it checks all the program at a time for to find out the any syntax errors in the program. The primary reason for compiling the source code is to create executable program. Create executable program because the executable program in the sense it is nothing but binary binary equivalent program. So 0 1 0 1 1 1 0. So like this, because the program which is written in the high level language cannot understand with the processor. So that's why that will be converted from the high level language program. It will be converted into the this executable program. And examples of compiler based languages are C, C++, Java. So this is a compiler. First source code we are applying to the compiler. Then the compiler will generate the machine code or object code. Then it will be the output. And coming to the instruction types. So already we know instruction. Instruction is a command to the processor to perform specific operation. So these instructions based on the operation, the instructions are mainly classified into the three types. The first one is the data transfer instructions, and the second one is the data operation instructions, and the third one is the program control instructions. So data transfer instructions are the instructions that are used to copy the data from one location to the another register, that are called data transfer instructions. So the data transfer instructions are also called copy instructions. Copy instructions, because they are copying the data from one location to the another location. The next one is a data operation instructions. So the data operation instructions are the instructions that are performing certain operations on the data stored on the registers. They can also called data manipulation instructions, because they are manipulating the data present in the registers. So these data operation instructions are again classified into three types, that are arithmetic instructions, arithmetic instructions, logical instructions, logical instructions, shift instructions, shift instructions. So these instructions perform arithmetic operations like addition, subtraction, multiplication, division, etc. And logical operations are performed AND operation, OR, AND, OR, XOR. These are all operations. And the shift operations are, they perform three types of shift operations: logical shift, arithmetic shift, circular shift. So these are the data operation instructions. And coming to the program control instructions. Program control instructions are the instructions that are used to transfer the program control from one location to the another location. That is called program control instructions. So in this picture, we have seen some definitions on introduction to the computer organization. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.